Hello, everyone, and welcome to our Under the Hood session about how to provision CloudGuard network security for Azure using Terraform. And give us 15, 20 seconds so that more people can join, and we will kick off in a very short amount of time. Thanks. So, hi again, everyone. Thank you for joining. We're here with Gustavo Coronel, who is a very experienced, wonderful cloud security architect in the Americas. Gustavo, thank you for presenting. This is going to be a very exciting session about how to deploy CloudGuard network security gateways for Azure using Terraform. So, Gustavo, why don't you take it away?
Thank you. Hello, everybody. Good morning, or good evening, good afternoon, whatever you happen to be. We are going to be talking about deploying a checkpoint lab using Terraform. The reason for this are many. The most popular is sometimes we need to test something. We, of course, don't want to mess up our main environment. It's something that we need to test quickly. So trying to catch up or become familiar with how do you deploy a cluster, how do you deploy a load balance scale set, how to deploy a single gateway, building the environment. It's kind of nice to have something that we can just simply run that builds the environment for us. So this presentation is about a set of Terraform playbooks that we have that will let you deploy a lab. And we try to put as much functionality into the lab as possible. I'm going to go through the playbook. I'm going to go through the lab. I'm going to spend the first few minutes explaining how to install Terraform for people that are not familiar with it. One of the nice things that I try to do is there's a lot of utilities out there that people can use, Packer, TerraGrunt, endless, right? I try to keep it as simple as possible. All you need to deploy this lab and use it is pretty much the basic Terraform executable. The lab should work perfectly okay in Windows, Linux, the Mac OS, and also on the Azure Cloud Shell, which we'll also see as one of the options. And the commands are pretty much the same in all instances. So, without further ado, let's get into it. Talking about installing Terraform, again, Terraform is a single binary or executable. It's very easy to install because you don't need a lot of dependencies that go with it. You can install the actual binaries from the link in this slide. And if usually you don't need step-by-step instructions, but if you do, I also added a link that has pretty good step-by-step instructions for Windows, Mac, and Linux components. So let me go ahead and keep on going, and we'll go a little bit into what that looks like as well. One of the nice things that we'll find out, and this is part of the demo, is that we don't even need to install Terraform on our system if we don't want to. If you open the Azure portal itself, Azure inside of the Cloud Shell that it provides has Terraform already installed. So I added this particular set of slides that show us where to find it, how to start it, and we will show it also in the demo, how to upgrade it if it needs to be upgraded. And pretty much everything that we have in this lab can be run from the Cloud Shell CLI on the Azure portal. So again, if you want to load Terraform on your laptops, on your desktop computers, if you want to download them on a VM, that's perfectly acceptable. But you don't need any of that. You can just run everything in this lab straight from the Azure portal if that is your preference. Okay, once you open the portal, and again, we'll go through this as well when I start the actual interactive part or the actual demo. We can load slides into the Azure CLI window by a little button. And there's a single file that needs to be uploaded, which is the Azure Lab lab.tgc. When that decompresses, it decompresses to a number of directories and subdirectories as indicated. It is not a big deployment. It's about 75K, but it has everything that you need to deploy the lab. One of the things that you realize or notice is there's a lot of different directories. And the reason that I did this is because sometimes you may want to build the entire lab. And if that's what you want, I put a little shell script in here. The shell script works on the Azure CLI. It works on Macs. It works on Linux systems. For Windows, you probably would need to do an equivalent batch file. But if you look at the build, it's very, very simple. All it does is switches directory and runs the Terraform commands. I also included a teardown. So once you finish playing, if you want to tear everything up, or if you want to start from scratch, you can simply just run the teardown script, and that breaks down the entire lab. But if you don't want to install everything and tear down everything, the reason that I did multiple directories is because it allows you to choose different things. So you may want to do the VNets, build the VNets, and maybe just a single gateway, or maybe you'll want to deploy a cluster. Maybe you want to deploy VMSS. Sometimes you want to use your own manager. Sometimes you want to have a manager in the cloud. So I try to give you options. Maybe once the lab is built, you just want to delete one of the components. So you can go into these directories and do a destroy just for that section, and the rest of the lab will be untouched. Same thing. One of the nice things that lets you do is if you want to upgrade to a different version of the HA cluster, for example, you can destroy the one that comes with the lab or not deploy it at all, and copy this directory with a different image that has the version that you do want to run, and simply execute it, and it will install that particular cluster in the same place that it would on the normal one that comes with the system. So moving on. One of the things that we will need to do in order to allow Terraform to build the entire environment for us is to give it a set of variables. Those variables should include your client ID, your client secret, your tenant ID, and your subscription ID. If you're using the Azure Cloud Shell CLI, you can simply log in into Azure at that CLI, and it uses your portal credentials. If you want to do that, you can. And while you do that, while that session is up and running, your portal credentials are active. However, I find that the best, most useful way for me is to give it what's called an environment, a set of environment variables. And this slide has the main four environment variables that you will need. Again, client ID, client secret, tenant ID, and subscription ID. I don't want to get into the wormhole of how to create the service principal, the set of accounts that you need to log into the system. But there are several links that explain how to do it. Maybe you don't have the rights to do it, but you can ask for those rights. You will need contributor access. So if somebody is creating a service principal for you to build this lab, tell them that you need contributor access. If you're building your own, please give it contributor access. There is, I did add a link up here that goes into some detail on how to create a service principal, either from the Cloud Shell CLI or from the portal itself. But the nice thing is that environmental variables, which is how I want to feed those credentials to Terraform, are very handy because you can usually set them the same way on Linux, Mac, or Windows Terminal, or the CLI. There is one difference in Windows, which is instead of export, you may need to use set. So give it a try. If your environment doesn't understand, it's usually Windows. If it does not understand export as a valid command, just change everywhere you see export to SET. A good reminder is for everything, unset will get rid of them and will wipe them from your environment. So just remember, to do a set instead of an unset if you have Windows. If
So,
you want to know,
Gustavo,
yes.
so let me just interrupt you for a second. There was a question in the Q&A.
Yes.
The command to uncompress would not be tar xzvf azure-lab.tgz. It's in the Q&A.
Yes, yes. That is how you untar it, and I was actually going to go through it during the interactive piece of it or part of it. So definitely, you can also use, depending on where you are, you can right click on it and it will decompress on a Mac. You can use some sort of uncompressing in Windows that understands star, and several utilities do. But yes, once you get the TGC, that's what you're going to need. I'm going to be uploading the TGC at the end of the presentation, and you should be able to download it. And I want to keep it updated, so I will be probably adding updates to it with additional features. So with that, I would love to do a quick poll, because one of the things that I would love to know is what is the level of a cloud experience and so forth and so on that that people have. So I'm going to go ahead and put the poll up. And while you guys do that, I want to explain one last thing about environment variables. One of the nicest things about it is if you use them, you don't have to keep these credentials inside of your playbooks, inside of your scripts. So if your scripts move or somebody copies them or somebody sees them, they will not be compromised because the variables are not anywhere inside of the Terraform playbooks themselves. We have a very nice swath over that spreads over all experience levels. It's almost even across everything. Okay, one really convenient thing that I found with environment variables is if you close the CLI window or close your terminal window in Unix, close your terminal window in Mac, close your command window in Windows, in variables, all these secrets go away. So the only way to get to these secrets is usually for somebody to steal your computer because you're adding them to your computer environment. But you can unset them at any time if you're not using them anymore, or simply close your terminal window and they are gone. While that terminal window is open, you can run all the Terraform commands and everything will authenticate correctly because those credentials are there. Okay. Once you and remember, we'll actually go through a lot of these steps through the interactive part. But once you deploy the lab and deploy all the directories, if you go into the directories, all you have to know is basically 4 commands in order to deploy the lab or destroy the lab. Terraform init basically initializes the directory, loads the providers, which is all the information that it needs to know to run the scripts that it's seeing. It needs to get some information from the Terraform site, and it downloads that into the directory. You can run Terraform init multiple times. Usually just one time is all that is needed. If you run the build script, it will run Terraform init for you. If you make changes into the lab because you love the lab, but you know some Terraform, you want to start making some changes, or even if you don't know Terraform, but you see some replacements that are easy to do, maybe change the IP ranges or change the name of some of the gateways or whatever. I normally like to run Terraform init again. If all you're changing is variables, it should not make a big difference, but it's always a good idea. A Terraform plan is the second command that we're going to be running. It actually looks at the entire playbook and sees what you're going to do and gives you a list of what it understands you want done. Oh, okay, so I'm reading this. You're going to create this. You want to delete this. You want to make changes here. And it shows you that. And it gives you a chance to look at it and be sure that that's what you want. Again, on our system, if you want to run the lab just the way that it is, the plan is pretty much not going to show you anything that you don't know. But basically, that is why it's used, and it's always a good idea to run it. Finally, Terraform Apply actually executes everything that is on your scripts. You can add dash auto approve to it, a parameter to it. If you do not do that, it will stop right before it's going to start making a change and will ask for you to say yes. And if you just want to go ahead and say yes, then it will basically execute. If you use the auto approve, it will just go into it right after you press apply and believe that you gave it permission to do every one of the changes. Another quick poll at this point, right before I talk about destroy. In order to eliminate everything that's described in the specific directory, or to eliminate everything, we're going to be using the Terraform destroy command. It's basically just the opposite of Terraform apply. You can use the same parameter, dash auto approve. If you want to destroy and you don't want it to ask, are you sure? Type yes. So with that, I am going to run another quick poll, which is basically, I just want to have an idea of a lot of beginners with Terraform here, people that are experienced with Terraform and just wanted to get some extra playbooks for examples. So whichever your level of experience is, just let us know on the poll. I'm going to give a few minutes for the poll to run, and then we'll continue. Okay, so we got we got also a pretty nice spread, but at least pretty much everybody that is in here has at least heard about Terraform and what it is, which is great because I forgot to explain what it is at the very beginning. Of course, it's an orchestrator. It allows us to automate installations of creation of architectures and destroying architectures in the cloud. The great add-on that it has, or what the claim to fame is, that is idempotent. So what it means is it remembers everything that you did before. So when you change your script, it will basically just change whatever you change your script and leave everything untouched. So we'll probably see some of that as we move along. Okay, let me go ahead and end that poll. And I'm going to go basically through the modules themselves. And so you understand what each one of the modules does. And again, if you want to learn Terraform, you can dive into the directories and just look at the code that's there. If you don't want to learn or know anything about Terraform, all you want to do is some automated way to deploy the lab, you can just run the build shell, or you can actually take a look at what each one of these components does and just do a Terraform init, plan, and apply, like you will see me do in a little bit. Okay, so the VNets directory has everything that is needed to build a quick and basic environment. It builds an on-prem VNet at the bottom that is going to replace or take the place of your regular on-prem. We want to do this because it's a lab. You probably want it isolated. You may not want it to connect to your regular site. If you do want it to connect it, that's fine. You can connect to the landing zone using ExpressRoute, using VPN. But if you don't, you can actually just run some sample machines on the on-prem VNet, and they will basically connect through the landing zone and through the spokes that the VNet directory builds. The landing zone will have a Windows jump box deployed in there. As with everything here, you could change that to a Unix system. You can tell it not to deploy a Windows jump box at all. I like to have a Windows jump box there because if I'm going to be browsing to the internet from the environment, if I'm going to be connecting to websites or whatnot, it's kind of nice to have that there. One of the nicest things that it does also is it allows you to download Smart Console, which is the client they're going to need to manage the management server that's going to be deployed as part of the lab without you having to run Smart Console on your on-prem device at all. If you want to, you can. But if you don't, you can basically use the Windows Jump Box for connecting via SSH, for SFTPing in and around the environment, and RDP connectivity is all that is needed because it deploys with a public IP. There's also 3 Linux machines that are deployed as part of the lab on the first directory. Again, you can comment those sections out or leave them there. You can change the size of the machine. The 3 machines that we deploy are very small. They are basically 1 CPU and half a gig of RAM. They are just the smallest standard Linux deployment. The reason I did Linux is because Linux lets you not only ping and do curls, if you wanted to do some web browsing from those boxes, but it does TCP dump. So if you want to do any sort of troubleshooting, things are not flowing the way that you want them to, you can actually run TCP dump on any of those 3 boxes and see if the packets are actually getting there and if the boxes are replying to those packets or not. So this is the basic environment. There is a mystery spoke up here called the route server spoke. We're going to need that in order to experiment or play with the Azure routing service, which is what allows us to get rid of UDRs if we don't want UDRs. It is part of the lab, and we'll get to that in a second. Let's keep moving on. The second directory is the deployment of a scale set. You may or may not want to deploy a scale set. If you run the regular build, it will put it there. If you want to run the script but not do a scale set deployment, you can comment that particular section of the script and it will not run anything in this directory. But the nice thing about deploying this is it is the most common deployed infrastructure that Checkpoint has in the cloud. So if you never played with a scale set, this is a great way to do it. It will deploy a scale set, and it is also great for you to test the automation for the auto provisioning piece, how we build and automatically provision the systems, play with scaling things up or down. So basically that is what the directory number 2 allows you to do. Directory number 3 deploys the management server. Again, as with everything, you don't have to deploy a management server, but I'm giving you the option to do it. The nice thing about it is maybe your management server is not already at 8120 and you want to play with 8120. Maybe you don't want to turn on the CME and start building templates in your regular manager. So you can do them on the management server that you deploy in the cloud. It makes it very easy to connect to because it gets deployed right next to the Windows job box that you can have to run Smart Console. So again, the environment is supposed to make things as easy as possible. One of the things that we can do if you deploy the management server is I have Terraform scripts as part of this build that will configure things in that management server. It will build a CME template for you. It will connect to a data center in Azure for you, which will let you play with dynamic objects in the cloud and with tags. It will automatically deploy rules. So having the manager deployed in the cloud is not only safer for your own manager, but a little convenient if you want to see examples of how some of those configuration files are built or how they work. Okay, next slide is creates a DMC VNet or landing zone. The reason this exists, or the reason I wanted to put this in the lab, is because I frequently get asked, I have a partner. The partner is going to connect via VPN. The partner is going to connect or is already in Azure, and they want to connect to us at high speed. What is the most secure way to do this? Or they simply want to do the ingress, egress. Anything that comes from the outside, they want to do that on a separate VNet, not their main landing zone. So it's very, very convenient. We build it, or Terraform builds it. If you basically do the apply on the DMC VNet directory, it's going to build that system. It's going to build a sample partner VNet with a system in there that can try to send traffic across. It's going to build a peering connection between the DMC and your main system, not for traffic to flow through in this direction, but to allow the management server to send policy installations into the firewall that we're going to deploy in here, which leads us to the next directory, the HA cluster. Since we deployed a scale set on the main landing zone, I decided or selected to deploy a cluster on the DMC. One of the reasons I put a cluster here is if you're using the DMC for ingress, one of the things that people do not like about scale sets is the fact that it does a NAT hide, a source NAT hide of any traffic that comes from the internet, and it hides it behind the firewall IP. For many implementations, people actually want to see that client IP out into the internet without any sort of translation. If you go through an HA cluster, that is possible because the HA cluster does not need to do an inbound source NAT. The reason is there's only one system that is live processing the traffic, so it doesn't need a NAT to tell the recipient which gateway to send the reply back to. It will always send it to the correct system. If you want to do ingress egress on the HA cluster, again, to test out functionality is recommended, and you can hit the spoke VNets in this direction as well. And you can also do policies in the cluster to allow the partner to come in and connect with the systems inside. It allows you to do NATing. So if you want to hide the partner VNet IPs or your IPs from a partner, you can use that cluster to do so. So again, no source NAT ingress traffic is the main reason I put this here. You could choose to deploy a scale set in here as well. Okay, the numbers are a little bit messed up here because I added this at the last moment. And I let you know right here, I added a single gateway directory build at the last minute. The reason I did this is because one of the things you're going to find out when you play with the lab is you may want to be debugging routes. You may make some changes. The routing is not working the way that you want to. And you suspect that maybe there's a routing issue on the subnets where the scale set is deployed. You cannot see effective routes if all you have on a particular subnet is a scale set. You need a full-blown VM of some type. So what I did, which I thought would be very convenient, is I elected to deploy a single gateway on that same subnet, the same two subnets that has a scale set. I did it way up on the subnet. The number is 200 for the IP, while the number for the scale set is very close to the beginning of the subnet. But the nice thing about having a single gateway there is effective routes do not work. So you can see what the routing looks like for those subnets without having to guess what the scale set is looking at. Since this is a much simpler setup, I made this the default for a lot of the provisioning. So if you run the build, a lot of the traffic is going to go through the single gateway instead of the scale set. But you can change things here and there. But I made a note here. The cluster configuration script, which we'll see, will provision this gateway on Smart Console and will point any static routes to it at the beginning by default. Okay, moving on. The configuration scripts. Okay, so we deployed a single gateway, we deployed a DMC, we deployed a cluster, we deployed a scale set. But right now they're not configured. They are just in what's called the initial policy state, right? So this is a lab. You want to be able to get up and running as fast as possible. So one of the things that included were configuration scripts for the management server. The configuration scripts do a lot of things. They create an Azure data center connection so that the management center can talk to Azure back and forth. It creates a CME provisioning script so it can automatically provision the scale sets that we created on step number 2. It automatically syncs to the cluster and pushes policy. So the configuration scripts allow you to have some sort of configuration in the management server that you can use right from the beginning. It also adds 3 or 4 basic rules that you can push to your lab system that let you SSH into the systems and so forth and so on. It also adds a NAT hide for egress into some of the systems. Again, you can do everything the configuration script does manually if you're trying to learn, if you want to experiment, if you just gave up and want something quick and dirty that will provision everything for you, the manager configuration script will do it. I broke it down into 2 pieces. One of them manages or builds the configuration for the scale set. That's the first one. And the second one, the CP Manager cluster configuration, configures the cluster and the single gateway. The reason I broke it into 2 pieces is because the first piece that does the scale set also configures the CME provisioning and configures the scale set for BGP use. We need to do that if we're going to be using the route service to get rid of UDRs. Again, you don't need to know BGP. It does all that configuration for you if you run the configuration scripts that are part of the system. Okay, we're near the end of the lab. The last piece that the lab is going to add is the route server. The route server is a service in Azure that allows you to talk BGP to the Azure Fabric. It allows you to learn what the Azure Fabric knows as far as routes are concerned, and it allows you to advertise routes into it. The policy that I created with the configuration script basically tells the scale set, advertise yourself as the default route. It does it, it injects that into the Azure routes server service. If you notice, there's connections between the service and just the spokes. And what it does is it advertises to the spokes and the spokes only what the next hop would be for their traffic to flow. And it would be pointing to the scale set as a default. And we will see how that looks on the interactive session. If you have UDRs deployed, the UDRs will always take precedence. If you want to use the BGP piece, then what you do is you get rid of the UDRs and allow the advertisement to be the default. And you can look at the effective routes if it's working or not. Finally, the script adds UDR static routes as well. The reason is you may not want to experiment with the Azure Route service. The Azure Route service is the most expensive piece of the lab. Everything in here can be shut down, but the route service cannot. And the route service costs about $10 a day. So by the end of the month, you're going to be around 300 plus change for having the Azure Route server if you leave it on all the time. So one of the nice things about, again, having everything in, discrete modules is that I can come in and destroy the route server when I'm not using it. I can destroy it and redeploy it. If I redeploy it, the systems reconnect to it. If I destroy it, the connection is lost. So you are not incurring any charges why that is not connected. But if you're not using it, you're going to need UDRs. So by default, I actually add UDRs so that if you actually want to play with the route service, what you need to do is simply delete the UDRs that get built. Okay. One more slide, and I'm going to share my screen and sort of play with the environment so you can see what it looks like and what it does. This last screen has to do with errors and warnings. I ran this lab hundreds of times. 99% of the time it runs without issues, but sometimes it will give you some types of errors. The errors may be because you made a change and you forgot something. The error may be because you made no changes, but for example, in the region you're deploying, there's not enough resources to build everything the lab is building. There's not enough space to create the cluster or to create the manager, to create one of the Linux boxes. Probably there's space for that because they're very small. If you see an allocation error, that is what it means. It means that Azure just ran out of capacity in the region that you're trying to deploy the lab in. It is temporary. The capacity volumes in Azure go up and down continuously. If I see that allocation error, I just go have a donut, come back later, give it 15 minutes, give it an hour. The best time to run everything and to build everything is late at night or very early in the morning, because the utilizations in most zones are low. Again, Ash depends on the region that you're in. So if you're deploying in the US region, US time zones are what you want. If you're deploying in Asia Pacific time zones are what you want. But if you do it late at night or very early in the morning, there's no more capacity deployed in any of the regions. The API answers very, very fast. So you actually save some time building and destroying, because it doesn't have to wait for Azure to catch up to what you're trying to do. Okay, so with that, we're going to move. I'm going to stop the slides, and I'm going to share my screen, and we're going to play a little bit. Let's let me see. Oops. Let's go ahead and double check that everything's good and do an end of the slides. And I'm going to go ahead and share my screen.
Just, Gustavo, just before you start sharing, just take a note of a couple of extra questions. See if there are any that you want to answer.
Okay. Okay. Oops. There are questions.
You don't have to answer them all now.
Yeah. I know. Let me. Yeah. Give me 2 seconds. Let me share my screen and up. But you're right. I cannot answer the questions without sharing the screen. Well, yeah. So let me go ahead and answer those questions first. Okay. So let me see. Where to download the package that has all the playbooks? You can download it from here. It's not up yet. And I did that on purpose. I apologize. I just didn't want people just grabbing it and start playing with it without at least hearing an explanation of what it does. So I'm going to go ahead and upload that at the end of the presentation, but you should be able to find it with all the links for this presentation. Next question, this is the same one. Where do we download the Azure Lab TC file? Again, it's going to be in here. Is there a GitHub repo with these scripts? Not today, but there will be. I wanted, again, to make something to start that was as simple as possible for people that have never run Terraform. So I didn't try to go into this is how you get clone GitHub depots or get files from there. All you need to do is just download the TEC and uncompress it. But yes, probably we will be putting this lab in a GitHub repo, and probably after somebody that knows Terraform even better than I do, takes ownership of it. I have to admit, one of the nice things about Terraform is that it's really easy to use. One of the sad things to admit is I'm not a big or great programmer, but Terraform is flexible enough that it's very easy for me to just grab the modules that exist and put them together. So that's what I did. Okay, let's see. I think those are most of them. So let me go ahead and share my screen again, and let me see. And move into here. So assuming everybody can see my screen, I want to play a little bit with what I did. So let me do a couple of things here. Once your lab is deployed, one of the things that I did is I tried to put CP Lab on everything. I tried to put it either on the resource groups or on the names of the objects in the cloud. The reason that I did this is because sometimes when you destroy, not everything gets taken out because it times out or little things here and that. So after I run the destroy script, after I break the lab down, I like to do a search for CP Lab on the top search bar in Azure. And that will tell me if, A, you forgot an interface or there's a resource group that's lagging behind, and I can go in and manually clean it up. Since this is not a permanent environment, we don't have to worry so much about the state of it. So if state is something that you're concerned about, you want to make sure that Terraform keeps track of all the changes, then you need to make all the changes in Terraform. In a lab environment, for the most part, I don't care. So I don't care whether Terraform keeps track of the state or not. I make changes manually on the lab all the time. And when I destroy, some of the things may be left behind because Terraform doesn't know about them. But again, I just destroy them manually and I just rebuild back at the end of it when I need it again. If you do a filter for CP Lab, you will see everything. For example, I'm listing virtual machines, showing all the virtual machines that got deployed. One of the things that I like to do is I list the virtual machines because I can click at the top, select every single virtual machine on the CP Lab environment, and shut them down. If you do this, you can keep the lab up, and for the most part, it would be at very little cost because all you have active is going to be VNets and route tables and peering links with no traffic going across. And that way you don't have to rebuild the lab the next morning, the next day, or the next hour to get everything back, right? So it's very, very easy to do the selection for the virtual machines, click at the very top, and then say stop. That will shut down all the machines, and there will be no compute costs for those. One of the things that you got to remember is if you have a scale set, then you have to remember that there will be a scale set. CP Lab is part of the scale set name. So if you do a search for scale sets under CP Lab, you're going to see it. The way I shut down the scale sets is I go to the scale set, I click on it, I go to scaling, and I change the scale set number to 0, and I save that. And that zeroes out the scale set. They get deleted, but it doesn't matter because when I change that scaling number back to 2, the new set of scale systems will come up. And remember, auto provisioning is running on the management server. If you configure the CME or you let the lab configure it for you. So it will see those systems and automatically add them to the management server again. And let me go ahead and show you what some of that looks like. Hosts, lab manager. Continue. Okay, so we're talking about provisioning the system. Provisioning the system gets done by a template that resides on the management server. If you use the lab configuration scripts, that template is going to be built for you. So if you go here to cd var log cpcme and do a listing, you're going to see that the configuration scripts added something called bootstrap.sh. It adds it there because along with the basic template, it configures the scale set gateways as they come up, where you deleted them and replacing them with 2 new ones, whether you're going from 2 to 4 systems, whether you're killing one of them because you decided that you messed something up by mistake and you want to rebuild new. The auto provisioning script will kick in, will provision it, and configure it. If you want to know what that bootstrap script says, of course, you can cat it. Let me do that. And again, it's very, very basic. It's not a big configuration. Mostly is configuring BGP. So if you go through these lines, you're going to see that it's setting up the BGP, it's setting the AS to 65100. You may want to change that AS number if you know BGP and you are using it or conflicts with something. 65515 is the AS number for Microsoft, for those who know a little bit of BGP and are interested in this. So that always stays the same. But basically, that's one of the configuration pieces that gets done here. The other one is the auto provisioning script for this for the CME. The CME is the cloud management extension. It is a process that runs in the management server that is constantly looking for gateways to provision. The provisioning script builds those for you. It has the management server name. It has the scale set name. It turns on some scales for you, some blades for you. Again, you can download the CME guide and play with this configuration. You can add things to it. You can change things from it as well. Okay, so let's see what else we want to go to that I want to talk about. The shell. Let me see if I have any one of these. Here we go. Reconnect. Okay, so if you are at the portal, and let me bring this down, or let me go to actually let me switch to a regular portal window. If you are at any portal window, there's this little icon here on the top right that opens the CLI window. The CLI window is going to open, sort of minimize at the bottom of the screen. You can bring it up or extend it. If you want to load anything into the CLI command, you can come in here to that little icon that allows you to upload systems or download files that I have here. If I do an ls in here, you can see that I have my Azure Lab TC, which I uncompress using tar XBF. So you want to do tar XBF and then the name of the TC, and that basically deploys the whole setup in here. Again, you can deploy this in Windows, you can deploy it in the Mac. That's perfectly okay. If you do it here, everything, of course, it's in the directory. If I can do an ls, you're going to see them here. That's all the directories: VNet, Hub BMS, CP Manager. Everything that I talked about is already here. And you have two particular batch scripts, one called build, one called teardown. And if you look at them, they are as basic as they can possibly be. All they do is they just cd to the particular directory, run the Terraform plan, init and apply, and that's it. So it's the easiest thing in the world. The lab, when you deploy it, if you do the building everything, it's going to take about an hour. The reason is usually the Azure Route Server is the biggest culprit of this. The Azure Route Server service takes about half an hour. The rest of the lab takes about 20 minutes, 15 to 20. So if you want to run the build and just comment out the Route Server service at the beginning, you can go ahead and do that, and it will deploy everything but. And since the UDR route tables are part of the script, everything should have connectivity at the very beginning, even if you're not advertising any BGP. So let me see if we have any additional questions. Let me stop sharing for a second and move over to questions. Oops. Hey, when did we start supporting the route server configuration? We didn't make an official announcement. The reason we didn't is because there's not a lot of special things that need to happen for us to support the route servers. The service is BGP. Checkpoint has talked BGP to BGP peers, whether they happen to be Cisco routers, whether they happen to be anything. And that's all the Azure Route Service is. It's just a BGP peer. So all that we're doing is connecting to it. If you want to learn how we connect to it, how we advertise to it, that is one of the purposes of the lab. You can look at the BGP configuration. You can see how it's peering. You can play with the BGP commands. And actually, I'm going to do those if there's not a lot more questions, because we have some extra minutes to play with. But the whole idea is that you can use the lab to learn how we interface with it, how you can change those policies to advertise additional routes, and so forth and so on. Okay, so that seems to be it on the questions. So let me do a couple of additional poll questions. Let's see. The first one, it's if we're going to make additional changes to the labs with time. I mean, either myself, if I have time, or somebody else that wants to play with it and makes changes and contribute to it. If we're adding things to it, I want to have some idea of things that may be important to you. By all means, you can always send us a note. But I added some options that I was thinking of adding to the lab. I can see that some people want to know about the Azure Virtual WAN. The current lab does not have a Terraform module for the Azure WAN, but we are building one. My understanding is that it's going to be ready by the end of the week. So if you want to play with deploying our systems in a V1 configuration, we will be able to show you those scripts pretty soon. There's a SD-WAN integration is very popular. My number one reason for deploying the Azure Route Service is to integrate with SD-WANs. The only reason I didn't do it is I wasn't sure whether we should just use the Checkpoint SD-WAN, of course, or there was a popular request for specific SD-WAN vendors that you would like to see integration with. Also, we plan to expand the labs, so maybe an AWS lab, so forth and so on. So we will, of course, add multi-lab connectivity with that. If you want to play with AppSec as part of the ingress, we probably wanted to add that to the lab as well. So those were some of the things that we were considering. Okay, I'm going to go ahead and end the poll for now. And let's do the last one, which is, of course, if you have any questions that are not covered by this, or you are going to do a deployment that touches some of the things that the lab works with, you can also reach out to us. We can answer additional questions. We can give you workshops. We can go a lot more in-depth into it. So we can, of course, offer a much more customized one-on-one interaction if you connect to us. So we're always interested in hearing from you, because everything that we build, of course, is to make your life easier. So the more you let us know how to do that, the better it is.
And let me just add, just for anybody who hasn't noticed so far, I'm sorry, I should have mentioned it earlier in the webinar in the beginning, that at the bottom of your screen, there are a whole bunch of attachments, including some of the links that Gustavo has in his presentation. You can download these slides, of course. And of course, you can also access the recording of this webinar afterwards, which should be up and available, within a few minutes after this is finished. So you can refer to this in the future. You can take the slides and use them in the future for yourself, or give them to a colleague. But you can also access some of these links. For example, schedule a demo, to talk to, whoops, don't know what that says. The second one is, sorry, my editing was bad. It says Works Talk with my account manager. I'm not sure about that.
Work talking is what we do.
I'm not sure how it says discuss cloud security challenge. Okay, so you see, I did a copy paste inside a workshop. You can see that answer number 2. So I'm sorry about that. I'll fix it for the next time. To err is human. To really screw up requires a computer. But yes. The other thing that Gustavo mentioned before is that Gustavo is part of the Cloud Security Architects team. So you can reach out to us either through this poll or in one of the links. And Gustavo and other people on the team would be very happy to set up like a workshop to understand your cloud security needs, and either face-to-face or virtual.
By the way, on those links where you can see the recording and you can have a copy of the slides, that's where the Azure Lab TGC file is going to be uploaded to pretty soon. I'm just going to do it right afterwards. If you have any questions, you can send them to me. I believe my gcornell@checkpoint.com is my email. I normally put it in the slides. I don't know if I did it this time, but you can actually reach out to any Checkpoint rep, and they will find me, or any of the CSAs, any of the cloud architects as well. So let me see. Do we have one more question? How is the BGP peering? How does it work? Well, let me go ahead. We have about 5 minutes. So I'm going to go ahead and show you how that BGP sort of works. Let me go ahead and share my screen again and switch over to that part. Okay, so let me go to them. To the actual gateways. I think I have them, or I had them open in here. Are they still open? Let me see. Control C. Ah, that's good. So Klish. And I can do that with that. And Okay, so if you saw the Bootstrap configuration script that I showed you, and actually let me do something better here, because I have this huge screen up here which I should really be using instead of the little one. So give me 2 seconds. Exit, and let me do this. Copy. And this is going to be a lot nicer on the eyes. Oops. Okay. By the way, and I'm going to add this to the TGC. I'm going to put a little file with passwords. There's 2 passwords that I use everywhere: VPN123 and lab use. and 2 potato chips. I'm going to write them down. So again, you can change those to anything that you want. Okay, so Klish. And okay, so show BGP configuration. Oops. Show configuration BGP. We are good. We have all 4 minutes. So here we go. Okay. As you can see, it's pretty basic. What we have here is I set up remote peering with 2 systems, 1053.036 and 1053.037. This is the Azure Route Service. The Azure Route Service is really just 2 VMs. And let me show you where they are. If you go here and look for route server, server, up. Is it? Now I can't. Let me see. I had it right at the top, but now, okay. There's more than one way to skin a cat in here. If I go to the ARSVNet, there we go. Here we go. So the route server is basically just a service. If you see the peer IPs, these are the 2 IPs that I peer to. Basically, it's just 2 VMs running BGP. So I'm going to peer with them using BGP, and that's what I did. And that's what this configuration does. Basically, just set a BGP remote AS connection. 655.15 is always the AS that represents Microsoft. Multi-hop needs to be on because it is on a separate subnet. It has to be on a subnet on its own. It also has an IP that Azure, a public IP that Azure requires for management. You never see the public IP. You cannot interact with it. But if you have any sort of restrictions in deploying public IPs, you're going to see that the Azure Route Service is asking you for it. Again, that's because of Microsoft. Once you configure the peerings in here and you configure the peerings in here, I just went to peer and did these 3 members. 1.4, 1.5, and 1.6 are the first 3 IP spaces of the scale set. When you delete and the scale set members get recreated, they reuse these IPs. So if 1.4 gets deleted, 0.5 and 0.6 are going to be active. If I delete 0.6, 1.4 is going to be reused again. So at any point in time, I'm going to have 3 scale set VMs all pre-configured to talk to the Azure Route Service. So that way, it doesn't matter where the scale set pops out or in and of existence. We're always going to have a connection. And in here, I can say show BGP peers. And I'm going to see that I have established BGP connection with the 2 systems. I can do some nice things here. I can say show BGP peer and put one of the peer numbers 10.53.0.36. And I can tab, oops, sorry, show BGP per, should be peer. And if I tab at the end, it'll give me what I can see. I can see what I'm receiving from that peer. This is what the Azure Route Service is advertising to me. I can see what I am advertising to the Azure Fabric. I'm advertising a default route. Since this is the service that connects to the spokes, it is connecting to the spokes. So again, this is for you to be able to play with all these systems. We are at the top. I think most questions have been answered. I will go ahead and upload the Azure Lab TGC in the next few minutes. This has been a pleasure. If nobody has any more questions, I think we can adjourn.
So, Gustavo, thank you very much. I really appreciate it, and thank you to everyone for joining. I'm not sure, Gustavo, if they'll be able to download it from this from the attachment group, because attachments have to be put up before the webinar presentation starts. That's in BrightTalk, so that's a problem. But what I will do is I'm going to send a follow-up email to everybody who participated
with a link,
with a link to this, and there's just one last question at the last second. Is there an official checkpoint doc for a route server? Not as far as I know, but maybe there's an SK. Is there an SK?
There's an advanced guide for BGP. Again, route server is just 2 VMs talking BGP. It's the same thing as connecting BGP to anything else. So if you have any questions about, I've deployed for the guides.
For the advanced guide,
I can probably not off the top of my head. If you do a search for the advanced routing guide for checkpoint, you will see them. But I've deployed over 25 to 30 route server environments easy lately, right? So any questions about route server, you can direct to me if you don't find those answers. But if you have played with BGP before, it's you set up 3 things: the IP, multi-hop, and basically that's it. And what route filters you want to learn or redistribute. It's pretty straightforward.
So Gustavo, just so that you know, there's some comments, not really questions. They say thank you for the great session, very interesting, well done. So thank you again, Gustavo. We're going to follow up with this in the new year, and we're going to add all the stuff that we were talking about before. And please continue to join our Under the Hood sessions. We really appreciate it. And please tell us what you'd like to see. We appreciate the feedback. We are here because of everybody out there. We appreciate you joining. We thank you for being part of our webinars. And we also wish you happy holidays and a good and relaxing and safe and healthy and happy end of year.
Yes.
Thank you, Gustavo. Thank you, everybody.
Okay.
Bye-bye.